Imagine for a moment that you are the captain of a ship.
Okay.
But, I mean, not just any ship. You're at the helm of this massive, incredibly complex vessel that's been engineered to handle, well, almost anything the ocean could throw at it.
Right. Storms, waves, mechanical failures.
Exactly.
Yeah.
There's a manual on the bridge for every single one of those scenarios.
Yeah.
You feel safe. The system is designed to be safe. You have backups for your backups.
It's a comforting feeling, that whole design basis, the idea that, the engineers have already thought of everything.
Yes. But then something happens that isn't in the manual. The ocean disappears, or, I don't know, the sky turns green, the rules of physics seem to warp, and suddenly that massive safe ship is gone. You're not a captain anymore. You are alone in a tiny leaking rowboat in the middle of a hurricane.
And you realize no one is coming to help you.
That's it. You're on your own.
That is a terrifying image, isn't it? But it's the central metaphor for what we're digging into today.
It really is.
We're exploring a training module for nuclear operators. It's titled Leading in the Black Swan, and it's by Dr. Charles Casto. And before you tune out thinking, I don't run a nuclear plant, trust me, this is about human behavior under extreme pressure.
It's about what happens when the rule book just burns. The core premise here is so gripping. When the design basis ends, extreme leadership begins.
And that phrase, design basis, is absolutely key. In any complex system, a nuclear reactor, a financial market, even a hospital, you have a design basis.
It's the box of scenarios you plan for.
Exactly. Inside that box, you're an administrator. You just follow the checklist. If X happens, do Y.
But the black swan is when you get kicked out of that box.
Right. A black swan is the unfathomable. It's an event that is, well, it's pretty much impossible to predict based on past data. And when that hits, you are in that rowboat.
And you have to switch modes.
Instantly, you have to go from being an administrator who follows rules to an adaptive leader who has to make up the rules as they go just to survive.
And the really scary part is, you usually don't know you're in the rowboat until it's way too late. The module makes this point that disasters don't just happen.
Yeah.
They're grown. They're sort of cultivated in the quiet times.
That's the pre-crisis phase. It's all about hubris. There's a line in the material that really sticks with me. Safe by design creates complacency.
Oh, wow.
When you are convinced the machine is perfect, you stop looking for the cracks. You stop imagining failure.
And that failure of imagination leads us straight to our first case study. And we really need to talk about the candle. When I first read this part of the prep, I genuinely thought I was misreading it. We're going back to 1975, the Browns Ferry nuclear plant.
It's a classic example of that pre-crisis mindset. You have two massive units running at full power, 2,200 megawatts.
A billion-dollar facility. Cutting-edge stuff for the time.
Right. And they have a procedure for checking for air leaks in these polyurethane foam seals.
And that procedure involves a candle.
A literal open flame candle.
I mean, just stop and think about that. You are in a facility designed to contain radioactive material, surrounded by complex electrical systems, and your high-tech solution for finding a draft is to hold up a flame and see if it flickers.
It sounds insane to us now, in 2026.
Yeah.
But you have to put yourself in that 1975 mindset. This wasn't seen as dangerous. It was just the way we do things. It was routine.
Casto calls it routine negligence.
That's it. It's not that these workers wanted to burn the plant down. It's that the normalization of deviance had set in. They'd done it 100 times before, and, nothing happened.
Until it did.
Right. On this one day, the draft sucked the flame into the foam. The foam ignited. And because it's polyurethane, it burned hot and fast.
And this wasn't just a small fire in a trash can. This thing took out the cables.
It was catastrophic. The fire burned right through the cable trays that controlled the safety systems. Specifically, it disabled the emergency core cooling system, the ECCS for Unit 1.
So because of a 5-cent candle, used to check for a minor air leak, they lost the primary way to keep the reactor from melting down.
Unbelievable. The document says they were within an hour of meltdown.
That is razor thin.
It is. And it perfectly illustrates that failure of imagination. The engineers designed the plant to withstand earthquakes and pipe breaks. They didn't design it to withstand a guy with a candle because they never imagined anyone would be foolish enough to do that.
But people do foolish things, especially when they get comfortable.
That's the danger of comfort. But there's another danger here, one that's even more insidious. It's not about doing something stupid. It's about knowing something crucial and just not sharing it.
The blind spot.
This takes us to the Pax nuclear plant in Hungary, 2003. This is a fascinating case because it all stems from a desire to be efficient.
Right, they had these fuel assemblies that had built up magnetite deposits, basically just rust and gunk. They wanted to clean them.
The good goal, right. Who doesn't want to be more efficient? So they brought in a contractor with this new cleaning tech. But there's a critical flaw in the plan, a physical limitation.
I was looking at the numbers here, and they are so specific. 12 minutes and 9 seconds. That's not a guess, is it?
No, not at all. That is a precise calculation. The engineers at the contractor firm knew, they had the physics data, that if the water flow stopped circulating in that cleaning tank, the heat from the fuel would boil all the water away in exactly 12 minutes and 9 seconds.
That is the cliff edge.
That's it. Once you pass that mark, you get a steam explosion. Now, put yourself in the shoes of the operator on the floor next to that tank. That number 12 minutes and 9 seconds is the single most important piece of information in the universe for you.
It's your survival horizon.
But they didn't know.
They had no idea. How does that happen? How do you have a ticking clock that leads to an explosion and you don't tell the person holding the bomb?
Information silos. The engineers treated it as technical data, just part of the design specs. They didn't view it as operational intelligence.
They didn't think, hey, the guy pressing the buttons needs to know this.
Exactly. So when the pump actually failed, the operators saw the flow stop, but they didn't panic. They thought they had time to troubleshoot.
They didn't know the countdown had started.
They were flying blind. They passed the 12-minute mark. The water boiled off. The fuel overheated to 1,500 degrees Celsius, and the tank blew apart.
All because of a failure to communicate. It wasn't even a technical failure at first.
No, it was a knowledge transfer failure. That's the lesson of PAX. In a complex system, if knowledge is siloed, you create blind spots. And in a black swan, blind spots will kill you.
Okay, so we've covered the pre-crisis, the candle, and the silo, but now we have to go darker. We need to talk about what happens when the crisis isn't an accident, but an attack.
Right. The module moves into the unfathomable with the situation at Zaporizhia.
This is where the manual doesn't just burn, it gets thrown out the window.
Zaporizhia represents the first military takeover of a civilian nuclear plant in history. There is no chapter in the operator training for what to do when tanks roll through the front gate.
The breakdown here is chilling. Kesto talks about the 7 pillars of safety being compromised. We see physical integrity lost due to shelling, supply chains cut. But the one that really hit me hardest was staffing.
It's always the human element.
We aren't just talking about people being tired or overworked. The document uses words like duress and torture.
It's a complete degradation of the human condition required to operate that plant. Think about the focus it takes to run a reactor. It's like brain surgery. Now imagine doing that brain surgery while you are effectively a hostage.
Your family might be threatened. You haven't slept properly in days.
You're working at gunpoint.
There's a term used here, identity shift. What does that mean in this context?
It means the people running the plant stop being workers. A worker clocks in, follows rules, gets paid, goes home. These people became veterans.
They entered a survival mode.
Yes. Their identity shifted to being guardians of a disaster. They weren't just doing a job. They were the only barrier preventing a catastrophe, all while under occupation.
It just changes the entire psychological baseline. You can't trust the systems. You can't trust security.
Trust resets to zero, and panic becomes the default state. Casto's analysis here is so profound. The human factor is paramount. We spend so much time designing safety pumps and backup generators.
But if the human at the controls is psychologically broken or terrified, the machine is unsafe.
It doesn't matter how good the hardware is.
This brings us to the fog of war. When you're in that rowboat, whether it's war like Zaporizhia or a natural disaster like Fukushima, you are just surrounded by bad information.
The pandemonium curve. In the first few hours or days of a black swan, you don't have data. You have fused data. It's this toxic mix of facts, rumors, fears, and bad sensors.
There's a perfect example of this, the empty pool theory.
Oh, yeah. This happened at Fukushima. A rumor started that the spent fuel pool was empty and the fuel was burning, releasing massive radiation.
And it was based on what? Nothing.
Basically nothing. A reflection, a bad camera angle, but that rumor traveled 5,000 miles to the decision makers in other countries.
And suddenly you have people in offices on the other side of the world making decisions based on a ghost story.
Exactly. They were debating evacuation zones and drastic measures based on a fiction. The lesson Casto drives home is, don't manage a crisis from 5,000 miles away.
You can't see through the fog from a conference room in Washington or Tokyo.
You have to trust the people in the rowboat.
So let's talk about those people in the rowboat. How do you actually lead when the world is ending? The module highlights 4 specific lessons from Fukushima that I think are incredible. The first one is so counterintuitive. Cement your feet.
I love this one. Imagine the scene. The Great East Japan earthquake hits. It is violent. The control room is shaking like crazy. Ceiling tiles are falling. Alarms are screaming.
The natural instinct is action bias. Run. Flip switches. Do something.
Fight or flight. But Shift Supervisor Ikuizawa did neither. He stood in the middle of that chaos and gave a command that sounds crazy. Don't operate the plant. Don't do anything until the quaking calms down.
Wow. That takes immense discipline. To do nothing when your body is screaming at you to do something?
About being the anchor. He knew that if they started flipping switches while the ground was still shaking, they might make things worse.
Right.
By cementing his feet, he signaled to his team, I am here. We are not panicking. We are going to assess, not react. He literally slowed down time.
So once the shaking stops, you have to figure out what's actually broken. That brings us to lesson 2, sense-making. And the tool here isn't some supercomputer.
No, it's a whiteboard.
The whiteboard of Naohiro Masuda at the sister plant, Fukushima Daini.
This is such a practical lesson for anyone. In a crisis, information silos form instantly. Everyone has a piece of the puzzle, but nobody sees the whole picture.
So what did he do?
He realized this. He started writing everything down on a giant whiteboard in the Emergency Response Center.
It sounds so simple.
It is, but it's powerful. He called it Team Sense. By writing it down publicly, he made the private public. There were no secret notes. Everyone saw the same priorities, the same facts, at the same time.
It kills the rumors. It just clears the fog.
Exactly. It creates a shared reality. When everyone is looking at the same whiteboard, you stop arguing about what is happening and start working on how to fix it. It builds momentum.
But you can't run on momentum forever. This was a long disaster, weeks. And that leads to lesson 3, the gas and the brake.
This is about physical endurance. The conditions at Fukushima were hellish. We're talking about operators in full hazmat suits, respirator masks, hauling 1-ton spools of cable by hand through deep mud.
And for 9 kilometers, I can't even imagine the exhaustion.
And the instinct of a leader is to say, push, we have to save the reactor, sleep later.
Of course.
But Masuda applied the brake. He forced them to stop. He prioritized getting them bento boxes for food. He made sure they slept. There's this wonderful detail that they actually had the soccer team lead morning exercises.
That seems almost absurd in the middle of a nuclear meltdown. Stretching.
But it's vital. It reestablishes humanity. It gets the blood flowing. The maxim here is, you cannot run a marathon at a sprint. If Masuda had burned his team out in the first 48 hours, they would have made mistakes on day 3 that could have cost them the plant.
He had to manage their biological batteries.
As carefully as the station's batteries, yes.
And finally, we get to the ultimate test of leadership in the Black Swan. Lesson 4, the necessity of defiance. This is the story of Site Superintendent Yoshida at Fukushima Daiichi.
This is the moment that defines the adaptive leader. The situation was critical. The reactors were overheating. The only way to cool them was to inject seawater. But seawater is corrosive. It ruins the machinery.
So injecting seawater means you are writing off the asset. You're destroying a billion-dollar reactor to save the core.
Correct. And corporate headquarters TEPCO and even elements of the government were hesitant. They were thinking about the asset. They ordered Yoshida to stop injection.
They wanted to wait, to analyze.
Protect the asset, even when the asset is melting down.
Unbelievable.
Yoshida was in the rowboat. He knew the physics. He knew that if he stopped the water, the core would melt, and the radiation release would be catastrophic for the public.
So he made a choice.
He turned to his team and told them in a hushed voice to ignore the order. He said he would pretend to stop it on the conference call, but they were to keep that water flowing no matter what.
That is incredible. He defied a direct order from the people who signed his paycheck.
He chose the operator's prerogative. He decided that the safety of the public was more important than the corporate asset or his own career. And Casto calls this Casto's mandate. Actions must be implemented faster than the progression of the accident.
If you wait for permission, you lose.
The accident doesn't wait for your board meeting. The accident doesn't care about your hierarchy. Yoshida knew he was the only one close enough to the problem to solve it. He had to act.
That's such a powerful place to land. It really shifts the view of what a leader is.
It's not just the person with the fancy title.
It's the person who knows what to do when the walls are falling down.
And that leads into the summary of roles the module provides. It gives us a framework. For the leader, there's the rule of presence. You cannot lead from the office. You have to be there.
And you have to communicate clearly. They call it the goalpost strategy.
This is a great tool for managing anxiety. In a crisis, the unknown is terrifying. People think, are we all going to die?
So you set boundaries on the fear.
Right. The leader needs to set the goalposts, define the best case and the worst case. The best case is we fix the pump in an hour. The worst case is we have to vent steam.
It turns the infinite gray terror into black and white options.
Exactly. It bounds the problem. It gives people a playing field they can understand.
And what about the operator, the person on the front line?
They are the guardian of the public trust. The source says you are the final barrier. It goes back to PAX. You have to demand to know the blind spots. You have to ask, where are the cliffs? How much time do I have?
You can't just be a passive button pusher.
No way.
There's a final philosophy in this deep dive that really struck me, and it circles back to this idea of heroism. The module ends with the concept of no more heroes.
It sounds harsh at first, doesn't it? Like we don't appreciate what Yoshida or the others did.
Right.
But it's actually a deeply compassionate argument. Dr. Casto is saying that if you need a hero to save the day, your system has failed.
We shouldn't have to rely on someone sacrificing themselves to fix our mistakes.
Exactly. We should design robust systems and, more importantly, train adaptive leaders so that heroic self-sacrifice is never required. We need to move from training for success, which is just memorizing the manual, to training for failure.
Teach people how to think when the manual burns.
So they can solve the problem without having to become a martyr.
It's about empowering the operator, not sacrificing them. The source leaves us with this heavy, haunting line. You may be the only thing standing between a bad day and an accident.
It's a heavy burden, but it's also the reality of the rowboat. When the storm hits, it's just you and your decisions.
So as we wrap up this deep dive, I want to leave you, the listener, with a question. We started with the candle at Brown's Ferry. A silly 5-cent item that almost destroyed $1 billion plan because it became routine.
The failure of imagination.
Right. So look at your own world, your team, your project, your family. What is your routine negligence? What is the 5-cent candle that you're using every day just because that's how we've always done it?
Where are you comfortable when you should be curious?
Because if you can find that candle and blow it out now, you might just save yourself from ever having to get into the rowboat. Thanks for diving in with us.
Stay safe out there.